Hello everybody and welcome back. Today's video is actually a really quick one. We're just going to dive into ragged arrays. And we've actually already seen some ragged arrays in the previous video, so that's why this is going to be so quick. But it's really just the understanding that Java is okay if your matrices, your arrays, your rectangles, whatever you want to call them, are not always the same size. We don't need to have every single row have the same number of columns, and Java is completely okay with that. We can do this by defining a 2D array as we know how, and then by picking the number of rows, but not picking the number of columns. This is going to allow us to create an array of int arrays, a 4-element array of int arrays. There we go. Now those int arrays are not actually sized yet, so every single one of those spots is actually going to be null right now. So if I go ahead and try to print out grid at 0, 0, it won't explode, but I am going to get null because it is null right now. I haven't initialized the position into any kind of int array. It is declared, grid at 0 does exist, but it isn't initialized. We can't do anything with it. There we go. This will show what grid at 0 is equal to. And it will be null. It will not be a memory address. So let's go ahead and just try that out so that we can prove to ourselves that what I'm saying is true. And we can see we're getting null. Now, if instead we did want to initialize this one, grid at 0 is going to be equal to a new int array of size 5. Now, if I try to run this, I will actually get a memory address because we have initialized that array to have space. We can do this with each individual array internally, and they do not have to be the same size as we've seen. Is equal to a new int array of size 1. Now, the main thing to remember here when we're working with jagged arrays is as long as you do this all the time, you will never have an issue, but we cannot rely always on just the first row to be our count of elements or the number of rows and the number of columns being equal. We can't make any of those assumptions. Pardon me, print array, and we'll pass in our grid. So if we go ahead and make this function, print, public static void print array, and we take in our array. We don't know what's coming in here. We don't know how many rows. We don't know how many columns. So our safest bet is always to go from 0 up to grid.length. And then internally, we need to go from 0 up to that row's length. So it's really important that this value is coming in and it's dependent on this for loop. So this isn't a hard-coded number, and we don't just write grid.length again because we have no guarantee that that is going to work. Even if it doesn't explode, it might not work because we could be missing elements. This also will allow us to then do a print statement like this, RC, separate each one, and we can sort of nicely space everything out, even though it is jagged. Now, we haven't actually filled this array yet, so let's go ahead and fill the array, and I will do it in a method so that we have something to print. Public static void fill array. Array. And this should look very, very similar. So I'm actually just going to copy paste this, except now I called it array. And instead of printing each of these spots, I'm just going to fill them with like a number. Let's fill them with R plus C. All right. So this will allow us to go through every single element in our array. And every single element in our array means every single int array in our array. This allows us to go through every single cell within a given row, within a given one of those int arrays. And then we'll just set the value equal to the row plus the column index as a way for us to fill our array with data. And then we can go ahead and print it out over here. All right, if we give this a quick compile and run, read the array length. Oh, Oh, whoops, I had set this to a 4-element array of int arrays, and I only assigned 3 of them. So of course I was hitting a null. I guess technically we can hit a null, and that should be okay. So what I'm actually going to do is I'll change this to a 3, so I set the null in the middle, and I will actually do something like this. If the array row does not equal null, then we can keep going through here. So this will allow me to check for this raggedness in an even safer way. We'll do it over here as well to ensure that we do not fall into this similar trap again. All right, let's go ahead and run this. Oh, this one should be grid. I just forgot to change the name. Just some very minor things there. There we go. If C is, why are we getting all blank lines? Oh my goodness. If C is greater than grid dot at R, let's make sure we change that around. There we go. Oh, what a day, hey? Okay, so what can we see that actually happened here? Well, our first array in our grid had 5 elements, and they were all filled up as expected. The second array in our grid had 3 elements, and it all filled up as expected. The third array was still null, and so we actually just jumped right over it. And then the fourth array had a single spot in it, and that filled up as expected. Now when we do our print array, the exact same thing happened. We printed this entire line, we got a new line. We printed this entire line, we got a new line. We went to go attempt to print this, but nothing printed out because the grid at spot 2 is null. So all we got was a fresh new line right here. And then we had our final row, which was not null. It had a single element in it. This ran once, and we got our final element, value 3, coming out. So we can see that we can print through jagged arrays. We just need to be really careful about how we do it. And that includes things like checking for null, making sure our inner loop runs over that R, the row, as opposed to the entire grid's length. And apparently we also need to be checking our signs, because on a Monday morning when I'm recording this, that is apparently a very tricky thing for me to remember. Ragged arrays are incredibly helpful for lots of different reasons, as long as we're using them safely. We can think about things like in a movie theater, as we saw in the previous week, and how different rows had different numbers of seats. Having that capability is incredibly important and allows us to only use as much space as we need for something like that. It just means we have to be really careful with looping through that safely and making sure we're accounting for all those different situations. As for the most common mistakes, other than forgetting something like this, making sure our row is not null, is accidentally forgetting that some of our rows are going to be smaller or longer than others. And so printing out data that is either missing data or trying to print out data and getting that index out of bounds exception is incredibly common for, pitfalls and places to trip us up. But that's really all there is to this, given that we've already kind of seen ragged arrays before. And in my next video, we're going to sort of wrap up this topic by drawing some reference diagrams. And I'll make sure that we draw a couple, including ragged arrays, so we can see what those look like in memory as well. Thanks, everyone, and I'll see you there.